Hello everyone, my name is Akshit Dhruv and my teammates are Lal Cheta, Deep Gandhi and Jai Kishan Satikuva. We have made a project on a topic disk scheduling algorithm for the subject operating system. We have created basically a GUI using the Python language, and the view you can see on the screen is of the GUI. Here we have created three different frames. That is, if he or she does not know the answer of a particular values, then he or she can directly come over here and search for the algorithms and directly get the answers. Now, if he or she does not know the algorithm itself, then he or she can come over here, can select the algorithm and can learn about it. And now, if at last wants to compare something, then he or she can come over here. One by one, we will see all the different frames and we will see how it gets the output. Now, suppose if I put the values over here, and suppose I will take just now the values from here itself, and if you want, I will change the values over here. If you want like something like 120 comma 30, I will add on my own. And after that, I will add initial head position as a 50, maximum cylinder as 250, and minimum cylinder as 0. Now you can see the total number of seek operations is equals to 500, and the seek order is also given over here, that is 30, 120, 41, 11, 92, 60, 34, and 79. That is from 50 it will go to 30, then 120, 41, 11, 92, 60, 34, 79, and at last it will go to the 176. That is at here you can see. So this is how the LIFO will give the output, and you can see the exact seek time spent is at 500. Now suppose if I change the algorithm and I will click on the SSTF, then accordingly I will get the output. The total number of seek operations is 204, and the seek operations order are as follows as I have written over here. Now suppose if I change to scan, and if I run the algorithm, then see you will get the output. Here it is a mixed up, like because of the mixed up, like suppose it is 60, then 79, after that 92, 120, 176, 249, 41, 34, 30, and after that 11. So you can see over here. After that, if I click on the look algorithm or the C-scan algorithm first, then you will see the output. That is, it will go to the 50, 60, 79, 92, 120, 176, 249, 0, 11, 30, 34, and after that 41. Now, if I click on the look algorithm, the look algorithm will be 50, 60, 79, 92, 120, 176, 41, 34, 30, and 11. Now suppose if I want to save these answers and as a text file, then this will open the directory. This is the best part, that is wherever you want to save, you can save. Suppose if I want to save in Windows E drive, and suppose if I want to save in drive, desktop over here only, and the algorithm name is suppose loop, and if I save as a type as a txt file, and I will click on the save button, then it should have saved over here, that is look.txt. See, it will save all the details over here. So this is the good thing, that who or he or she wants the output to be saved, then he or she can save. Now suppose after look I will have quick look on clook. Yeah, it's working, right? You will find the different outputs. And suppose after clook, if we go to the FCFS, then FCFS will also run. Yeah, you will see. Now suppose from simulation, that is, if he or she does not know the algorithm, it's completely blind, then he or she can come to this section, select the any one algorithm and can run
In
this.
FCFS, the requests are addressed in the order they arrive in the disk queue.
So you can see it will print the details about the FCFS, and with that it will give the output, it will show the graph. So basically he or she can understand what is going on in that algorithm. Suppose if I select LIFO.
In LIFO, last in, first out, algorithm, newest jobs are serviced before the existing ones.
See, you will get the details about the LIFO. If I click on C-scan and if I click on run,
INCScan algorithm, in which the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the requests from there. So, the disk arm moves in a circular fashion, and this algorithm is also similar to scan algorithm, and hence it is known as C-scan, circular scan.
see, you will get the details about the C-scan. Now suppose he or she wants to compare that which algorithm is best, then he or she can come to directly to this section. Will paste something like initial head position as 50, maximum cylinder if I keep as like this time as 300, minimum cylinder as 0. And suppose if I want just to check FCFS. Now if I am clicking just FCFS, then obviously the best algorithm for the given value must be FCFS, as I am comparing FCFS only, not the other algorithms. And if I click on run, then see, I will get the output as FCFS. But if I compare it with something else, suppose if I want to compare LIFO and FCFS value, and if I click on run, you will see LIFO is 448 and seek time of FCFS is 510. That's why LIFO is having the best algorithm, is the best algorithm for the. Suppose now I click on each and every checkbox, that is I want to compare all the algorithms, and if I click on run, yes, I get the value of all the algorithms, and as well as the best algorithm for the given value is SST graph. Now suppose if I change the direction, then the algorithms which has this values based on the direction will get changed, and on the basis of that the best algorithm for the given value may change. Let's see what happens. Yes, if we click on see look with the left direction, it will have a seek time of just 155. So once using this visualization, you can have complete idea which algorithm is working best, which directions, which initial head values, maximum cylinders. So you will be able to do each and everything so simply using this. Thank you very much for watching this video.